Hello everyone and welcome back to my channel MiTutorials. This is the week 4 of the series Introduction to Python on my channel. In the last week's tutorial, we went through different conditional statements, the loop statements, the while loop statements, different functions in Python, how to create a function within Python, and then we also went through how to create a lambda function. In this week, which is week 4, we're going through a very important topic wherein we will be learning about Numpy package. Numpy is one of the very basic package which is available in Python, which you will be using very often whenever you are using Python. Now, Numpy is basically a package or a library which is used for computing within Python. Numpy is used to create arrays or matrices. It's also used to perform arithmetic calculations. The Numpy library in Python is intended to perform fast operations on arrays, including mathematical, logical, shape manipulation, sorting, selecting, etc. So let's go through that in detail. Now, I would like to tell you that in Python, we have lists that serve purpose of arrays, but they are quite slow to process. We went through the list in the earlier tutorials, but they are quite slow to process, and especially when the data is huge. So when you use Numpy arrays, they tend to perform 50 times faster than the traditional Python list. Now that is extremely fast. So let's get started with this tutorial. So the first step is you need to import the library within the notebook. So I'm assuming that you are using Google Colab. When you use Google Colab, the libraries are automatically available for you. You don't have to install them. But if you are using Jupyter Notebook or some other notebook, you might have to install these libraries first. So since we are using Google Colab, I don't have to install the library. I can simply import the Numpy library using the command import numpy as np. Now what this particular line of code is doing is it's importing the Numpy library and it is renaming this as np. Now if it will work even if I do not have the alias over here as np, because it is still importing numpy over here. So if I run this code over here, this will get imported. The numpy as a library will get imported, and then if I have to recall that particular library, for example in this cell over here I'm creating a numpy array over here, and if I have to call the numpy library, I will every time have to write the entire name of that particular library, which is numpy, and then followed by the functions which are available within that library. So to avoid writing the 5-letter word, what we do traditionally is that we rename this particular library or have an alias to that and call that as np. Now this is a very standard practice to have an alias to the numpy library as np. So let's import numpy as np. If I run the cell, it gets executed and np alias is assigned to the library numpy. Now let's look at how do we create arrays using numpy. So the way we do that is just like how we create lists, but in this case we are calling the numpy library. This is the numpy library. We're calling the numpy library dot followed by array. This is the function which is available within the numpy library, and then we open the parenthesis, and within the parenthesis we pass in a list of numbers which are getting assigned to an array. Now let's run this code and see what happens, and you will notice that this is exactly looking like a list which has square brackets. But let's look at the type of the variable ARR that we've created over here, and if I run this code over here, we will see that this is the class numpy nd array. This is meaning that this is an numpy array, right? It is not a list that we created earlier, but this is an array. Now we can also create a matrix using the numpy array, and to do that we will have to first open parenthesis over here and then have a square bracket, and within square bracket you need to pass in multiple lists. If you look at this code over here, you will see that I have a list and then followed by a comma that is separating the list, and then all of these 3 lists are within square brackets again, and then they are enclosed within parentheses. Now using the np.array function, I'm passing all of these lists within these parentheses over here. So let's run this code and let's call the variable over here, which is matrix, and you will see that it has now created a matrix with the shape 3 by 3. We can also create arrays using functions within NumPy. One of the function to create an array is called aRange. So it's called by np. So we need to call the library first, followed by the function which is available within that particular library. In this case, we are looking at the function aRange. So within this aRange function, you will have to pass in parameters. The first parameter over here is start. So this is the number that we are starting with. And the second parameter is the number until where we are going to stop, which is number 11 that I have mentioned over here, meaning that it is going to stop at 10, and the step size of 2, meaning that if you are starting from 1, it needs to add 2 to every number. For example, 1, and then it will add 2 to that particular value, it becomes 3, and then adds 2 to 3, then that becomes 5, and it will go on until it reaches the value 10. So let's run this code over here and see what happens. So you will see that we've now created an array with the numbers starting from 1 until 10, wherein after every number, the step number gets added to it, and then it creates an array until the number has been reached. Likewise, I'm creating another variable called arr3 over here and using the np.arange function. And notice that in this case, I had mentioned start is equals to stop is equals to. It's not mandatory. However, this was only to help you understand that the first parameter over here is referring to the start. The second parameter is referring to the stop, and the third parameter is referring to the step size. Now, if I run this code over here, you will see that we have values starting from 0 up till 110, meaning that the last value is excluded. So it's going to only return till 100, and this is the step size of 10. So we're getting the multiples of 10 over here. Within the NumPy library, there's a function called as Linspace. Now, what this particular function does is it creates an evenly spaced numbers over a specified interval. So let me run this code and show you what it is doing. So what this has done is it has created 50 elements of evenly spaced numbers between 0 and 10. By default, since I have not mentioned the number of elements that I want in that particular matrix, by default it takes 50. If you see over here, so this is the first element, second, third, fourth, fifth, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 into 5 is 50. It has created 50 even elements between the number 0 and 10. Now, to help you explain this better, I'm going to enter the third parameter over here, which is the number of elements that we want in that particular matrix. So if I run this code over here, you will see that it has now created a matrix of 2 elements, 0 and 10. Now, if I change this to 4 and run this code again, you will see that it has now created 4 equally distributed elements. So if you look at this particular example over here, we are saying that it needs to start from 0, go up till 10, and then have them equally divided into 3 numbers. So if I run this code over here, you will see that we have 0, we have 5, and then we have 10. Likewise, I have another example over here, starting from 0, go up till 2, and then I need 5 equal numbers. So you will see that 0, 0.5, 1, 1.5, and it goes up till 2. You can also create a matrix with 0 value. This function returns a matrix filled with 0 of the given shape, which is 2, 6. You will see that there are 2 rows and there are 6 columns. The first value within this list refers to the number of rows that you want, and the second value refers to the columns in that particular matrix. So it's saying that it is 2 rows and 6 columns. So if I change this to 4 and run this code again, you will see that we have 4 rows with 6 columns. Likewise, I can create a matrix with ones. So if I run this code, which is np.ones, I will get a matrix of 1 in all of the elements. So I can change this to 4 and still continue to get the value 1 in all of the matrix elements. Another function within NumPy is np.i, and you just need to pass in one parameter over here. I'm just passing a number 5 over here. You will see that the diagonal element in this particular matrix is 1 and the rest of the values are 0. and you can change this to 10 and run this code again, you will see that we now have a 10 by 10 matrix with the diagonal values 1 and the rest of the elements 0. So like I said earlier, NumPy is also used for arithmetic calculations. So let's look at some of the arithmetic calculations. So now I have two lists over here, list A and list B. We are creating a new variable called x and then performing addition of these two lists. Now remember, these are lists and these are not arrays. So what happens when you perform an arithmetic calculation on these two lists? So let's run this and see what happens. So you will see that instead of this performing an addition of the first value with the first value of the list B, meaning that I was expecting an output of 1 plus 6, which is 7, 2 plus 7, that is 9, but that has not happened in this case because these are lists. So if you look at the type of the variable x, you will see that this is a list but not a NumPy array. So when you perform a calculation, we saw this earlier as well, where we combined list using the operator plus sign. When you combine list, you will see that both of these lists combine and become one single list, and you will see all the values within that particular list. But this is not the case when you use the NumPy array. So let's create two arrays over here. We're using the np.arange function to create a list ranging from 1 to 5, and then another array called arr5 ranging from 6 to 10. So let's run this and see what happens. You will see that we've now created two arrays, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now on this particular, it might look like a list, but it is not. So if we look at the type of array that we created, so if I run this code, you will see that this is a NumPy array and not a list. It might look like a list, but this is actually a NumPy array. So we can now perform calculations on this. So let's run this code. So I can simply do the variable that we created, arr4 plus arr5. Now notice that this behaves differently when you use this within the NumPy array. When we did the same thing with the list over here, it combined the list and gave us an output of these two lists. Over here, it is performing a calculation. It is performing an addition when I use the operator plus over here. So it has added 1 plus 6, which is 7, 4 plus 9, which is 13, 5 plus 10, which is 15, right? Likewise, I can do subtraction as well of these two arrays. And let me quickly change the operator over here and run this code again. You will see that I now have the values 1 minus 6, which is minus 5, 2 minus 7, which is again minus 5, 3 minus 8, which is again minus 5, 4 minus 9, which is again minus 5, and at the end I have 5 minus 10, which is again minus 5. I can also do a multiplication over here. I can simply use the star operator and create a multiplication. So you will see now that we've multiplied 1 with 6, the value is 6. We've now multiplied 2 by 7, the value is 14, 3 with 8, the value is 24, etc. We can also perform the division by using the slash operator over here. It has now divided 1 by 6, which is 0.166, and the 2 by 7 with 0.28, etc. We can also do powers. For example, I will have to use the operator double star over here to know or to perform powers calculation. So what it is doing is it is now calculating 1 to the power of 6, 2 to the power of 7, etc. And this is the values that we get when we perform that powers calculation. Now let's look at how can we create a transpose of a matrix. So first of all, let me just get rid of this and let me call the variable over here. So we are creating a list using the arange function starting from 1 up till 10, which means that it is going to end at 9. So the value we've got as an array over here. Now let's look at reshaping this and creating a matrix. So I can use the function which is called as reshape and then pass in the parameters within that particular reshape function. So if I run this code, you will see that we've now created a matrix of using the arange that we created over here. Instead, earlier we had a list. Now this has been converted into a matrix with the shape 3 by 3. Now let's say you want to transpose the rows into columns, meaning that if you want this 1, 2, 3 which is in the row to appear in the column, we can use the function which is called as transpose. So I can just do c.transpose, open and close parenthesis, and run this. And you will see that this has not been transposed because we have not assigned the reshape to the variable c. So I'll just have to do this, assign this particular changes that we made to the variable c. Now that we have assigned the reshape function to the variable c over here, we can now run the transpose function on the c variable, and you will see that we've now transposed the matrix. We earlier had 1, 2, 3 on the row over here, but now we are seeing that 1, 2, 3 is on the column. You can also do the transpose on the c variable by just typing in .T. Remember, over here in this step, we are not assigning the transpose back to our variable c. That is why we are saying this. So let us quickly reassign this transpose function to the variable c so that it gets saved into that particular variable. Now that it is saved in that particular variable, now if I call the variable c over here, you will see that the matrix is 1, 2, 3 in the column over here. But when I do a transpose on c right now, you will see that the column has now been transposed to row. There are functions within NumPy which will help you find the minimum value and the maximum value. So let's run np.min. Within the parenthesis, we need to pass in the variable which is c. This will return the minimum value which is available in that particular matrix. Likewise, we have the max function. So if I run np.max, pass in the variable, you will get the value 9, which is the max value in that particular matrix. Now you can also access entries from a matrix. Let's say you want to access all the entries which are greater than 5. So I can run this piece of code over here. So what this is doing is, let me just add a new line over here. So I'm saying c greater than 5. So what this will return is, it will return whether it is true or false. It's saying false, this is true, etc. right? Now, if you want to get the actual values which are present in that matrix and which are only true, what you need to do is you need to pass in the variable c within the square brackets. Now, this will return the values only which are true. Likewise, I can do this and return the values which are greater than 2 in that particular matrix. Now, let's create a matrix of the shape 5 by 5 with the A range values of 1 to 25. So if I run this code over here, you will see we've now created a matrix of the shape 5 by 5. Now let's see how can we access certain rows or certain elements in a particular matrix. So let's say if I want to access the third row in this particular matrix, which is this. So I need to say n is our variable for the matrix that we created, and within the square brackets I'm passing in the value 2 over here, and you will see that this is now extracting the third row for us. Remember that the indexing value starts from 0, so this is the 0th row, this is 1th row, and this is the second row according to the index values. Now if I enter 2 over here and run this code over here, you will see that we are getting the third row from this particular matrix. Likewise, you can access the last row by entering -1 over here. You will get this particular row, which is exactly what we have over here. And if we do -2, you will get the last second row. Now let's say you want to access the third element from the second row. Our second row is this, and third element is 8. So what I can do is I can pass in the n. The first value within the square brackets over here refers to a row, and the second value within parentheses over here refers to a column, which is this is 0 and 1 second row, this is 0, 1 and 2, which is the third column. So if I run this code, you will see that we've selected the value 8, which is in the second row and third column. The value is 8. Now let's see if I want to access first two rows within the second and third column. So the first argument over here refers to the row and the second refers to the column. So I need the rows starting from 0 until the index value 2. Remember that the second index, the end index over here is excluded, meaning that it's going to fetch the first row and the second row only. This is the 0th index value. This is the first index value, and this is the second index value. Second is not included, so it's going to only extract the first and the second row. And then we have another condition to extract only the columns which are starting from first index value until 3, meaning that it's only going to fetch the data until the second index column. So this is the first 0th index column, this is the first index column, and this is the second index column. So our first index column is this, which is the second column over here, and then it's going to fetch until the second index column, which is this particular column over here. So let's run this code and you will see that we've now got an output 2, 3 and 7, 8. It has fetched the 2 rows with second and third column, 2 rows with the second and third column. Likewise, you can run this piece of code over here and fetch the first 2 columns in that particular matrix. You will see that we've now fetched. So when you mention something like this with a colon and not mention anything before or after, it considers that it needs to fetch all the rows from that particular argument. And then on the second argument, we have columns starting from index value 0 until the index value 1, which is 0 and 1, meaning that the first 2 columns in this particular matrix. So if I change this to 3 over here, we will now get 3 columns and all the rows. So, but if I mention, let's say, a limitation here in the row, starting from the index value 0 until the 4th row. So if I run this, you will see that we've now got all the rows because you only have 0, 1, 2, 3, 4. So if I change this to 4, you will see that we've now got only 4 rows from that particular matrix. Now you can also change values for that in that particular matrix. So if I run this code over here, which says n in the square brackets 2:3, I am retrieving the second row from this particular output. So if I change this to 4, you will get 2 rows as an output, but I need only the second row. Remember that this particular value is excluded, meaning that it's only going to extract the row which is 2:2. So the output is 11, 12, 13, 14, 15. And if I have to assign values or change values of that particular row, I can simply do is equals to 10 and call that particular row again, and you will see that we've now got all the values as 10 in that particular matrix. So if I recall this matrix over here, you will see that this particular row has been changed to 10. So with this, we come to an end of the week 4 tutorial. So just to do a little bit of recap, we learned how to import a library, our first library, which is Numpy. We learned how to create an array. We saw how to create a matrix. Then we learned about some functions such as Linspace, zeros, ones, and I, etc. We also learned how to perform arithmetic calculations such as addition, subtraction, multiplication, division. We also learned about how to transpose a matrix. We also learned how to find the minimum and the maximum value within a particular matrix. We learned how to access matrix, and we also learned how to change values within a particular matrix. So that's it guys in this particular tutorial. I hope you found this tutorial helpful. You've learned something new today. Please consider subscribing to my channel for more such tutorials.